Hi, Henk Akkermans here. Supply Chain Dynamics Chapter 8, Pilot Error. Clip number 1. The flow in engineering. So, let's have a look at engineering. Engineering is two stages in this model. Basic engineering, detailed engineering. The distinction is pretty straightforward. Basic engineering is the big chunks of the plane, which are later detailed out in the detailed engineering. The way that we conceptualize engineering here is in terms of a number of design documents that have to be completed. A bit like a manufacturing process then. So there's a pile of work up here which needs to be done, and how quickly you can do that depends on your design capacity, but also on the current quality of your designs and how long it takes on average. If the current quality is pretty low, the likelihood is pretty high that you'll be making some mistakes. We'll define basic design quality further on. So when you do that, you complete your designs, and the more designs that you have completed, the bigger your completeness of your basic design becomes. A value between 0 and 1, which is the ratio of the number of designs done so far divided by the total designs required. We'll need that further on in the model. So the design capacity up here, how do you determine that? Well, that depends on how much capacity you need. Up here is a first order negative feedback delay, so an adjustment process where you try to make the basic design capacity in line with the capacity that's needed. There's a maximum amount on that, we'll be playing with that later on. And the design capacity required depends on how much work you still need to do over a certain development delay. Now to quality. Well, we define quality as the absence of flaws, basically. So we assume that in every development task there are some flaws inherent to it, some mistakes you need to fix, and you haven't figured them out initially. The more there are of those, the fewer, the lower that your design quality is. Let's say that initially we assume that there is 100 basic design flaws and that you can never have a quality bigger than 1. Then how many design flaws are still undetected divided by the total number, and then that ratio subtracted from the maximum quality. That's your basic design quality. How do you improve this then? How do you find more and more of these design flaws? Well, partly you do that, partly. A lot of these flaws you find in the next stage, in the stage of the detailed engineering, because you can't really figure out what's happening very well if you are only in your current phase. You find out the flaws in basic engineering if you try to detail that out. There's a certain percentage of so the completeness of the detailed design then also determines your fix rate over a certain fixed delay. Then there's the option of rework. Suppose that a customer comes along somewhere in the design process, as they did in the A380, it comes with additional design specs. That means that you have to redo some of the work. That also means that you've got some new flaws that you didn't have to solve earlier on, but there's a recycling of design work basically then. Okay, so that's basic engineering. Detailed engineering looked very much similar, but one main difference is that it doesn't start immediately. So here we've got all these detailed designs waiting to be developed, but depending on how far we want the basic design to be completed, this will start. So there's an if-then statement. If the completeness of the basic design is at least as high as we require it to be, then you can start transferring all this back into the pile of work that has to be done, the detailed design work. And the rest is identical to the basic engineering. Only we have, I believe, 1,000 design tasks rather than the 100 that we have in basic engineering. So that's it then.